Okay, today we move into section 7.4. We will multiply radical expressions, and once we know how to do that, we are going to be able to do something called rationalizing the denominators. So let's get started with these warm-ups. Go ahead and pause the video here and see how you can do. Okay, go ahead and see how you did there. Only thing I'd like to point out in number 3 is remember how you have to simplify the square root, whatever method you prefer. You have to utilize absolute value brackets around the x, and in the end, once you collect the like radicals, you factor out the square root of 3x. You cannot simplify the 2 plus 8 times the absolute value of x anymore. Make sure you leave it in parentheses. Okay, our first objective today will be multiplying radical expressions. Sometimes you're going to distribute, sometimes you're going to FOIL. In letter A here, we are going to distribute since we have just this single term times two terms. So I'm going to distribute the cube root of y. And what's nice is, since this is a cube root and both of my other radicals are cube roots, I'm able to just multiply the radicands. So cube root of y times the cube root of y squared is just the cube root of y cubed. And cube root of y times the cube root of 2 is just the cube root of 2y. Now I look to simplify these if I can. The first radical does simplify. Y goes into, or 3 goes into 3 one time, so I can pull out one of these y's. No absolute value bracket since my index is odd. And the second radical does not simplify. So that's it. Now in letter B, since you have a two-termed expression times a two-termed expression, we are going to FOIL. Okay, remember FOIL is first, outer, inner, last. So when we multiply our first terms of each binomial, we have 4 times the square root of 3 times the square root of 3. Our outers would be, since this is a minus, this is minus 4 times the square root of 3 times 5 times the square root of 2, and so on. And now we start multiplying these radical expressions. Now make sure that the indices are the same, which they are here. So we only multiply the 3's because the 4 is not underneath the radicals, so the 4 is going to stay. So this will be 4 times the square root of 9 minus 4 times 5, which is 20, times the square root of 3 times 2, which is 6, plus the square root of 6 minus 5 times, I multiply the 2's, I get the square root of 4. 4 times the square root of 9, since the square root of 9 is just 3, 4 times 3 is 12. Minus 20 times the square root of 6 plus the square root of 6. Square root of 4 is 2. 5 times 2 is 10. Collecting our like terms, 12 minus 10 is 2. And then we have some like radicals in the middle. We end up getting negative 20 plus 1, which is negative 19 times the square root of 6. In something like letter C, you could use the same method. You could just FOIL, or if you recognize this as difference of two squares, this will save you a little bit of time. So if you remember your difference of two squares, we have seen many times this year. So a plus b times a minus b is just a squared minus b squared. This is the special case where we have that, where a is the square root of 5 and b is the square root of 7. So we have the square root of 5 squared minus the square root of 7 squared. Now remember, anytime you're squaring a radical with, anytime you're squaring a square root, as long as the index and the exponent match up, they cancel out. You're just left with 5. Here we're just left with 7. You're left with negative 2. So that is multiplying radical expressions. Go ahead and try these checkpoints and see how you can do on it. Okay, go ahead and check to see how you did on these checkpoints. Only thing I'll point out, something we haven't seen in letter C, we were squaring a binomial, so if you're comfortable, just write it out as the binomial times itself and FOIL it. Or if you're comfortable with square double square, it's a little trickier here because we have radicals, but square double square still works. Something else I want to point out, anytime you have a term that contains the radical, some of you may have written this as 4 times the square root of 5 times y. That is correct. However, you typically want to put the factor that's the square root at the end, like I did here, because some times it is misunderstood and it appears as though this y is underneath the radical. So typically just make sure you put the radical factor at the end, as I did. Okay, let's move on to rationalizing the denominator. Basically what rationalizing the denominator means you cannot have radicals in the denominator. Okay, and you can't have fractions underneath the radical as well. So I would break this square root of 2/3 up as the square root of 2 over the square root of 3. Now we are not allowed to have a radical in the denominator, an unsimplified radical. And since we can't take the square root of 3, I need to rationalize the denominator. Why we say rationalize the denominator is because right now the square root of 3 is an irrational number. It's a decimal that goes on forever and it doesn't repeat. So I could rationalize this denominator. I can make it a rational number, the denominator. So the way that I'm going to do that is I need to, since I don't have a perfect square in the denominator, I need to create a perfect square in the denominator. And the way that I can do that, since my index is 2, I would need 2 of these factors 3 to occur underneath the radical in order to pull something out. So I need another 3 down there, so I'm going to multiply by the square root of 3. And I can't just leave it at that because I would be changing the value of this expression. So whatever I multiply the bottom by, I need to multiply the top by as well. Now when I multiply straight across, which is how we multiply fractions, I get the square root of 6 over the square root of 9. I now created a perfect square in the denominator. The square root of 9 is 3. So I really didn't even need to write this step, this square root of 9. Just know that since I have 2 3's and my index is 2, the square root of 3 times the square root of 3 is the square root of 9. A little rule I like to teach to help you remember anytime you're multiplying the square root of something times itself is this right here. Since my index is 2 for a square root, I would need 2 of these. Square root of a smiley face times the square root of a smiley face is just a smiley face. The square roots cancel out. This will help us transition into letter B. If we had cube roots, we would need to create a perfect cube. So I would need 3 of these, whatever it is. Cube root of a smiley face 3 times cancels out all of those, and you're just left with the smiley face. So for letter B, when I break this up as the cube root of 7 over the cube root of 9, I need to create a perfect cube down here. Now you need to look at 9 as 3 times 3. Factor it if you can. So I factored 9 into 3 times 3, so I can see I'm very close to creating a perfect cube down here. I would need 3 of the same factor. I already have 2. So I just need 1 more of those cube root of 3's. And remember, I have to multiply the top by whatever the bottom is as well. So when I multiply straight across, I get the cube root of 21. And in my denominator, since I have 3 3's, the cube root of 3 times 3 times 3 is just 3. I would then look to see if I can simplify the cube root of 21, which I cannot. Letter C, square root of the numerator over square root of the denominator. I need to create a perfect square in the denominator. I have 1 5. I would need 1 more. I have 1b. I would need 1 more. So I'm going to multiply top and bottom by the square root of 5b. Remember, the square root of a smiley face times the square root of a smiley face is just a smiley face. You don't even need absolute value brackets. It's just going to be 5b. Up in the numerator, square root of 10bc, which does not simplify anymore, so you're done. Now in letter D, it's already, the quotient rule of radicals has already been applied for us. It's already broken apart. Now I need to create a perfect cube in the denominator. So what I should do is factor that denominator, the radicand of the denominator, any way that I can. I can rewrite 49 as 7 times 7, and then we have an x there. So to create a perfect cube, I need the same factor to occur 3 times. I already have 2 7's. I only need 1 more. I only have one x. I need two more. So I'm going to multiply top and bottom by the cube root of 7x squared. This will create a perfect cube for us down here. What would the cube root of this be? Well, I have 3 7s. Cube root of 3 7s being multiplied is just 7. Same with 3 x's. I can pull out an x. Then my numerator would be 7ax squared underneath the cube root, which doesn't simplify at all. Okay, example 3, we continue to rationalize the denominator. However, we step it up a little bit here in that there are two terms in the denominator, at least one of which contains a radical that is not a perfect square or a perfect cube or whatever. So what I'm going to do is multiply top and bottom by what's called the conjugate of the denominator. Conjugate, C-O-N-J-U-G-A-T-E. So the conjugate of 2 plus the square root of 7 is just 2 minus the square root of 7. All you do is you just change the sign in the middle. So one of them's a plus, one of them's a minus, and remember we have to multiply the top by that same thing. So why is that good? Well, if you're multiplying these denominators, we basically just have difference of 2 squares. So let's start with the denominator. Remember our formula for difference of 2 squares. You could FOIL this if you want, but if you remember the formula, it's just 2 squared minus the square root of 7 squared, which is 4 minus 7, which is -3. So notice how we no longer have a radical in the denominator. That's how you get rid of the radical in the denominator whenever you have 2 or more terms. Now up in the numerator, in this case, sometimes we have to FOIL, but in this case we have to distribute the 3. We get 6 minus 3 times the square root of 7. You can't multiply the 3 and the 7 because one's under the square root. And you could factor this. Sometimes you don't really need to bother, but in this case we are going to 1, 2. I have a GCF of 3, and I can factor that out, and I'd be left with 2 minus the square root of 7. So when I write this as 3 times 2 minus the square root of 7, I see I can do some canceling. The 3's cancel, and I'm just left with 2 minus the square root of 7 divided by a -1, so I can divide the -1 into each term. So I'd be left with -2 plus the square root of 7, or in other words, square root of 7 minus 2. In the next example, again, we're going to multiply top and bottom by the conjugate, which is the square root of 5 plus the square root of 2. Our numerator, in this case, we actually have to FOIL, as we multiplied radical expressions earlier in the lesson. When you FOIL that numerator, this is what you get. You don't have any like radicals to collect, so you really just have to leave it at that. And then the denominator, we have difference of 2 squares. It will be the square root of 5 squared minus the square root of 2 squared. So I just copy the numerator down on the next step. And then our denominator, we end up getting 5 minus 2, which is 3. This does not simplify anymore, so you're done. We rationalize the denominator. We no longer have irrational numbers in the denominator. Okay, let's take a look at these checkpoints. You have 9 of them here: D, E, F, G, H, I, J, K, L, and the closing question. So why don't you go ahead, take a few minutes, and see what you can do with the remaining 10 problems. Okay, some of these are definitely a little challenging, so I want to point a few things out before we continue. Something like letter E, I need to create a perfect cube down here. So I need 2 more 6's, and then I can have just the 6 down in the denominator. And in the numerator, we end up getting the cube root of 108, and sometimes you're done at this point, but we have a lot of simplifying. In fact, 3 steps worth of simplifying left to do. Cube root of 108, largest perfect cube that goes into it is 27 4 times. Cube root of 27 is 3, and then 3 over 6 reduces to 1 over 2. So we still had a lot of work to do left, and the way that we could and should start doing these problems before we start simplifying before we start rationalizing the denominator, like I did here, we should maybe simplify first if we can. Like in letter E, 3 over 6 reduces to 1/2. So I can really write this as the cube root of 1 over the cube root of 2. Cube root of 1 is just 1 over the cube root of 2. Now I can begin to rationalize. So I need 2 more 2's down here. I need 2 more 2's down here. So basically the cube root of 4, multiply top and bottom by the cube root of 4. I'm left with the cube root of 4 over, down here we end up getting 2. So you get the same thing, but a lot easier if you can simplify first. For instance, letter F, the square root of 4 simplifies to 2. So do that first and then worry about rationalizing the denominator. That will save you more time. Letter G, square root of 4 simplifies to 2. 2 goes into 5 2 times, so I can pull out 2 of those x's, and I'm still left with square root of x here underneath. Down below, 2 goes into 3 one time, pull out 1 of those y's with 2 left over, left with the square root of 3y. Now rationalize the denominator, multiply top and bottom by really just the square root of 3y. That will create a perfect square down there, and continue. Okay, go ahead and check your answers to these checkpoints. And J through L and the closing question, go ahead and check to see how you did. And finally, your homework is working out of 2 worksheets. One that we already worked on, 17 through 26 all from that worksheet, and 2 through 26 from dividing radicals, 23 problems total.